Okay, so today we want to talk about definite integral. So definite integral looks something like this, like, okay, this is what we did earlier. It's just integrate of x squared, for example. Now we're gonna have that two small little number up here. Okay, this thing is called a definite integral. Now what are you supposed to do is this. You're supposed to first integrate. So once you integrate here, how do you integrate this? It's x and then 2 plus 1, right? Yes, over 2 plus 1. Now you are going to change this from that stretched S sign to a square bracket, and then you're going to transfer this 2 number to the right hand side. Okay, so this is how it is written. Okay, so what do you do next? So it's like x cubed over 3, right? So this is 1 over 3 x cubed from 2 to 3. That's what it is called. And what you're supposed to do is you're supposed to, now since 1/3 is the constant, you don't really need that as well. And then it goes into 3 cubed minus 2 cubed. That means you are substituting this number into the x. Okay? Alright, so that's what it means. So from here it will become 1/3, and this is 27 minus 8, that gives you 19 over 3. Okay? So this is called definite integral. Now definite integral return a value. Okay, so whatever that you do, it becomes a value. Alright? Anyone want to ask what happened to the c? It gets cancelled off from both sides, right? Okay, so you have, now after you integrate, there is a c here. Yes? And then there is a c here. And then there is a c here, right? So it minus. So it gets cancelled. So you don't need to bother about the c, yeah? Okay, no need, that's it. So that is the answer, and that's all. Okay? Right, so this is called definite integral. Okay, let's try one more. Okay, so if you have something like, let's say, 4, 5 from, let's say, e 2x dx, so what would this be? So you integrate, it becomes e 2x, and then the 2 becomes a half, yeah? 4 to 5. And then again, the half has nothing to do with the variable. So e to the power 10 minus e to the power 8. Okay? So when you substitute x equal to 5, so 2 times 5 is 10. And then minus, when you substitute x equals to 4, 2 times 4 is 8. Alright? So we can factorize this somehow to say e to the power 8 over 2, and this is e squared minus 1. Okay? And then we're done like this. Right? So what do we use this definite integral? So mostly it will be area under the curve. So for example, you have a curve. That's not a curve. Let's say you have a curve. And then let's say this is y equal to x squared, for example. If you want to find something like this, let's say from 2 to 3, for instance. So this is exactly the same example that I did just now, right? So how do you find that area there? So it will become integrate x squared dx from 2 to 3. So these are the two numbers that 2 to 3 means. Okay? So this will be 1/3 of x cubed. Remember, you transfer that into a square bracket from 2 to 3. You transfer that two limits to the right hand side. It becomes 1/3 3 cubed minus 2 cubed, so that becomes 19 over 3. Okay, so 19 over 3 would be unit square, which is the area under the curve. Okay, now same thing. If it is a straight line, it would have been the same as well. Okay, so let me just show one. Let's say you have this straight line. This straight line goes, let's say y equal to x, for example. Let's do this fairly easily. So this from 0 to, let's say, 3. Okay? Now obviously, if you do your normal way, you will be able to find the area here, right? So how do you find that area here? So how do you find the area? So half times base times height, right? So this shape is a triangle, right? So what is the height there? Huh? What is the height there? Also 3, right? Because y equal to x, right? So the area here is half times 3 times 3, which is 9 over 2, yes? Now if you're going to integrate here, you integrate x dx because that is y there, right? So from 0 to 3, yes? So which is x squared over 2, right? From 0 to 3, yes? So it's half. So x squared, it will be 3 squared minus 0 squared, yes? Which is 9 over 2 unit square. That's exactly the same as how you would have done it using a straight line. Okay? So, you integrate.
What did she say? I didn't even hear her.
Yeah, that's how you get that x squared. So integrate, right? Inverse of 1, add 1 becomes a 2 divided. Okay? Right? So integrate x. Okay? Alright? Now just to emphasize that, now what is the meaning of area under the curve? So area under the curve, firstly, okay, let's go back a little bit. Firstly, there must be that 2 number. That 2 number is like a region from where to where. So that is important. And then secondly, it is also important that the meaning of this area under the curve is actually from the curve to the horizontal axis. So in here, we only do horizontal axis, so which is to the x-axis. So this is the area that we talk about, right? Now what happens if you have, let's say, if you have one particular type of curve that goes this way? Now in this sense, you would expect that after the integration, this number would give you a negative number. Okay? So the area, of course, you just take the absolute value. Right? But when you do an integration, it will give you that negative number. Yeah? So just for you to understand. Now in here, again, the area under the curve is from the curve to the horizontal axis. So that means it is like that. So that is the shaded region. That is the meaning of area under the curve. Okay? So that name is still the same, area under the curve. Okay?